Okay, a small ring P of mass 0.03 kg is threaded on a rough vertical rod. Okay, so let's see, mass of 0.03 kg means this ring has a weight downwards, which will be 0.03 multiplied by 10, which is common acceleration due to gravity downwards, and that causes weight. So 0.03 multiplied by 10 will be 0.3 newtons. Second word is threaded. Threaded means this rod is just passing inside the ring. So ring is free to move up and down on this rod. Rough vertical rod. Rough means there will be some friction which will try to stop it from sliding down. So there will be a frictional force upwards. Vertical means this plane is vertical, so weight is part of it. So we should interpret every word very carefully from this question. A light inextensible string is attached to the ring and pulled upward at an angle of 15 degrees to the horizontal. They have already drawn that, 2.5 newtons, 15 degrees to the horizontal. And inextensible string means it has no role whatsoever in the motion of the ring or stopping of the ring. It is just weightless string. Okay. The tension in the string is this. The ring is in limiting equilibrium. That means whatever is the force upwards is equal to the force downwards, and that's why it is not moving because of the limiting equilibrium. Okay. It is on the point of sliding up. Wow, this is very important. Sliding up. That means because of this force, it is about to move up. So the friction I wrote up is not up anymore, because since it is trying to move up, friction will join the weight. See, each step has some meaning. So let me erase the upwards frictional force so that it does not confuse us. All right, back to our question. Find the coefficient of friction between the ring and the rod. So I hope you're aware now. So there are two forces which are downwards. Then what is the force upwards? There will be a force upward which will be a component of 2.5 newtons. And because the angle is here, the horizontal component of this will be 2.5 cos 15 degrees. Wherever is the angle, that becomes the cosine component of the force. And the one on the opposite side of that line will be the sine component. 2.5 sine 15. This is the y component or vertical component. I call it sine component because I used sine with it. So this 2.5 sine 15 has to be equal to these two, and then we can find coefficient of friction. So let's write it. 2.5 sine 15 equal to frictional force plus 0.3 newtons. Let's bring 0.3 newtons to the left side, and frictional force is equal to the coefficient of friction they're asking times the reaction force. So 2.5 sine 15 degrees minus 0.3 equal to mu r. Okay, mu we have to find. Let's focus on r. We have not written r anywhere. R is the force which is normal, perpendicular to the motion. Then only it will cause friction. So which force is perpendicular to the motion? The motion of the ring will be up or down, and this is the direction. And the force we have in this direction is this, 2.5 cos 15. So we'll substitute this here. It becomes 2.5 sine 15 minus 0.3 equal to mu multiplied by 2.5 cos 15 degrees. So to isolate mu, we will divide both sides by this number, and it will get cancelled on the left side. We'll be left with 2.5 sine 15 minus 0.3 over 2.5 cos 15. I did not evaluate any one of them because I did not want to round off different parts and get an answer which is not accurate. Okay, so I'll just put the whole of this in my calculator and I'll get the coefficient friction. By the time I do this with my calculator, I would request you to subscribe to my channel and motivate me to make more quality videos like this. And if you have any question from IGCSE level or A and AS level, you can write to me in comments and I will make videos on your requests. Okay, after putting this in my calculator, I got coefficient of friction equal to 0.1437, but three significant figures, it will be 0.144. Question 2. A particle is projected vertically upwards with a speed of 30 meters per second. Let's visualize this. So it was thrown up and initial velocity is 30 meters per second. Okay, from a point on the horizontal ground. So this is ground. Show that the maximum height it reaches above the ground is 45 meters. So we have to show, right? We can't use this 45 meter. We have to arrive at 45 meters. So two things we need to keep in mind, that whenever something is thrown up, it ultimately goes at the highest point of its journey and stops. Stops means the velocity becomes zero. U is 30 meter per second for this, V becomes zero. The second thing you have to keep in mind that acceleration is always downwards, minus 10 meters per second square, because we have taken 30 as positive. So we have to take something downwards. Even if the object is going up, the acceleration is downwards. That's why it is slowing down and ultimately slows to V equal to 0. And now we know this formula, 2as equal to V square minus U square. We have everything, but we can't use S. We have to arrive at 45 meters. So let's not plug in anything in place of S, rest everything is with us. So 2 and acceleration is minus 10. S remains S equal to 0 square minus 30 square minus 20S equal to 0, 0. So minus 900. Square is not with this minus, so it will stay negative. So S equal to minus 900 divided by minus 20. Negative, negative cancel, and this comes out to 45 meters. We showed that the highest point, the maximum height is 45 meters away from the ground. Okay, let's move on to the second part. Okay, here it is. Find the time it takes for the particle to reach a height of 33.75. That means just before its highest point, they are asking us the time it takes to reach at this height above the ground for the first time. Find also the speed of the particle at this time. So first, let's find the time. We know that the height is 33.75. The initial velocity with which it was thrown was also in the same direction, 30 meters per second. Acceleration is minus 10 meters per second square. So we can use the formula S equal to ut plus half AD square. So S is 33.75, U is 30, time we want to find out, plus half times minus 10 T square. And this becomes a quadratic. 2 and 10 will cancel, so it will be minus 5 here. When it comes to the left side, it will become positive 5 T square. This 30T will become minus 30T, and 33.75 is already here, it stays positive. So now we have all three things with us, and we can find the value of T, rather we'll get two of them. They're saying for the first time when it reaches 33.75, for the first time. That means out of those two times, whichever is the smaller one, we'll accept that as our answer. So let's use our calculator to find the solutions straight away. By the time I'm doing this, I request you to please subscribe to this channel to motivate me to make more videos in detail for your benefit. If prank videos and gaming videos can get millions of subscribers, we can get thousands, isn't it? Alright, so the two times I got in this case are 4.5 seconds and 1.5 seconds. Clearly this time comes first and this will be our answer. This is the time when it reaches at a height of 33.75 meters. Okay, now we have to find the velocity at this time. So we know that v is equal to u plus at. We have to find u. We know it was thrown up by 30 meters per second. This velocity it was thrown at, plus acceleration is minus 10 in opposite direction, and time is 1.5 seconds. That's what we have chosen here. So now it becomes v equal to 30 minus 15, which is 15 meters per second. Question number 3 is a very repetitive kind of question. I've seen such a question many a times in exams, where they're saying that there are 4 coplanar forces. When they say coplanar forces, that means they are not vertical forces, they are horizontal forces. Just imagine these forces are lying on a table and you're looking at them from the top of the table. That's what they are. That means gravity is not part of this. Okay, forget gravity. And they have labeled them as F, 5 and 15, 25 newtons. All right. Given that the forces are in equilibrium, that means this point is not moving anywhere. So that means all the forces are balanced. Find the value of F and alpha. Whenever you have two unknowns at the same place, all right, try to find a sine equation and a cos equation involving the two. So to get that, first we should see which of the forces are in x direction and y direction. So this is x direction, positive x direction. This is y direction, this one. So we can see that this force is in x direction. Don't touch it. Keep it 5. Never divide it into any component. This 25 Newton is in negative y direction. Also don't touch it. Only these two forces, 15 newtons and F Newton, are at some angle to these two axes. So we will just change only these two into components. Let's start with 15 newtons. This becomes 15 cos 20 degrees. Whichever component makes angle with the real force, original force, becomes cos component. That means the other one on the other side of the force becomes sine. 15 sine of the same angle. Similarly, F, the angle alpha is here, so the component here will be F cos alpha, and the one on the other side will be F sine alpha. Okay, and that's what will give us sine and cosine equations. So since this whole system is in equilibrium, so the first equation will be involved 15 cos 20, F cos alpha and 5 Newton. They are the ones which are horizontal forces, y components. So let me write them here. 15 cos 20 is on the left side. It will be equal to the other forces on the right side, 5 and F cos alpha. I want to isolate this because I wanted only unknowns on one side. So I will write, let me write F cos alpha first. So this 5 goes here and subtracts from this. So I will write 15 cos 20 minus 5. I changed their places, okay? So 5 went here, became negative, and then both of them exchanged their places with this, right? Then I did not change their signs. I kept them like this. Let's name this equation as equation number 1, and let's make another equation with vertical forces. F sine alpha is on top. So F sine alpha will be equal to the two forces downwards. So it will be 25 plus 15 sine 20 degrees. Alright, let's name it as equation number 2. And now we have two variables, one of them must go, then only we can find the second variable. And the best, because they are multiplying, the best method will be to divide. Let's divide the equation number 2 by equation number 1. So f sine alpha over f cos alpha will be equal to 25 plus 15 sine 20 over 15 cos 20 minus 5. You might be thinking that since all of them are known, why don't I put them in my calculator and put their actual values here? That will do what? That will not give me accurate, as close answer as possible to what they want. That's why I'm keeping like this. Just uh, take care that you plug them well in your calculator. Everything will be okay. Now, the purpose of dividing was to get rid of f. We can cancel f now. And sine theta over cos theta we know is tan theta. So it will be tan alpha equal to 25 plus 15 sine 20 over 15 cos 20 minus 5. So alpha is tan inverse whole of it, which is again 25 plus 15 sine 20 over 15 cos 20 minus 5 whole of it. Okay, just put this in a calculator and you will get your answers straight. What else is straight is to subscribe to this channel. Please subscribe and motivate me to make more videos and help you to understand the concepts. The answer I got was alpha 73.2 degrees. This is what I got. Second thing is we have to find f as well. And for f we can use any one of the equations. Let me use the first one, f cos alpha. F cos alpha equal to 15 cos 20. Okay. F cos alpha is known to us now, 73.2 equal to 15 cos 20 minus 5. So f will be, this will divide to the other side because they are multiplying, so this will divide the other side. 15 cos 20 minus 5 over cos 73.2 degrees. Put this in a calculator and you get your answer. What I got was 31.5 newtons. Question 4 talks about a car of mass 1500 kg is pulling a trailer of mass 300 kg. So let's denote the mass of car by capital M, 1500 kg, and mass of trailer 300 kg. Along a straight horizontal road at a constant speed. Constant speed is a very key word here. Whenever they say constant speed, keep in mind the forward force, which is applied force, will always be equal to the resistive force, which is backward. Both of them will be equal. That's why there will not be any acceleration. The reason behind that is that we know that ma is F net, which is further equal to applied force minus resistive force. So if these two are equal, it becomes 0. That means F net is 0 and mass cannot be 0. Mass is fixed for everything. Acceleration will be 0. That means it's a constant speed. So that's what we interpret, that applied force and resistive force will be equal. That's what this constant speed means. And the speed itself is 20 meters per second. The system of the car and trailer is modeled as two particles. Let's do that. This is the car and this is the trailer connected by light. The light means that the rod which is connecting them does not have any role in the system. Okay, the power of the engine is 6000 watts. All right. There are constant resistances to the motion R Newton on the car. Okay, there is R Newton on this car and 80 Newton on trailer. That means whatever is the forward force which will be equal to these two resistances. Okay, these include air resistance as well as friction, so we don't have to look about friction. Okay, find the value of R. So we know our equation is this and we will use this one. F applied is how much? Oh, we don't know F applied. So let's find force applied. The force applied is applied by the engine. The power of the engine divided by the speed at which the system is going. That's how we find the applied force. And applied force will be, the power has been given as 6000 divided by speed is 220. So this cancel 300 newtons. So 300 newtons, which is applied force, will be equal to the resistive force, which are two forces R and AT. And that gives us the answer now. R will be 300 minus 80, which is 220 newtons. The R which is on the car itself is 220 newtons backwards. Let's go to the second part of the question. The power of car's engine is increased to 12,500 watts. So now there is new power, 12,500 joules per second or watts. The resistance force do not change. So R1 is, we got just 2 and 220, and R2 is 80 newtons. Okay, find the acceleration of the car and trailer and the tension in the rod. So two things you have to find, acceleration and tension. So we can use this equation, F net, which is MA is equal to the applied force minus resistive force. So applied force can you find again by this relationship, power which is 12,500 in this case, and the speed is given, yeah, it's given 25. So 25 times 5, 500 newtons. That's the applied force. So applied force is 500, resistive force, both of them together were 300. Okay, acceleration is with us now. Mass is how much? Let me see again. What was the mass? 1500 and 300. 1500 and 300 times A. Okay, so to both the masses are moving with acceleration A, and this is the difference of applied force and resistive force. It becomes 1800 A equal to 200. So acceleration, they were asking acceleration, find the acceleration, right? So it will be 200 over 1800, 1 over 9, which would be 0.1111 meters per second square. Okay, second thing we have to find is the tension. So let's redraw the system again, which will help us to draw the tension. So this is car connected with, this is trailer. There's a resistive force here which is 220 newtons. There is a resistive force here which is 80 newtons. Tension is here. Okay, let me write TR here. Tension is here. So let's focus only on the car. Only on the car, that will give us tension. Okay, I can take trailer also, but I prefer car. Okay, so we have a force in this direction which is 500 newtons. We found here applied force 500 newtons, and now we have an acceleration, so we can use the same formula MA equal to F applied minus resistive force. But since we are only focusing on car, keep the trailer out of it. So mass of the car is 1500. Yeah. Acceleration we just found out 0.11. Applied force on the car is 500 Newton. And resistive force are 220 newtons is here, and the tension is also in the backwards direction. It is connecting the trailer, so it is pulling the trailer. So it will be 220 and minus tension also. So let's do what? Let's bring this tension to the left side and we'll bring it to the right side. So tension equal to 500, rather let me write 500 minus 220 is 280. This is 280 and minus this one which comes here 1500 multiplied by 0.1111. I'm writing 0.11 only, and this will give us our tension. I will find this out. Meanwhile, when I'm finding the total tension, please subscribe to my channel so that I make such detailed videos with learning points for you in future too. And after putting this in my calculator, I got 113.33 newtons, but we need 3 significant figures. This is enough. 113 newtons. Question number 5 is about a VT graph. Details of this are given here. You can pause the video and read them if you want to. Otherwise, I will just explain what is happening in the graph here. So I can see here that at the starting point, when time is 0, the speed is 0. The velocity is 0 not in any direction. So if the body is starting from a point O, here it is stationary, and then it is starting to move with a different velocity every time. Its velocity is increasing till this level, but the straight line denotes that it is a constant acceleration, and we don't know this value. Let's call this value x. Okay, so let's visualize this. It is going away from O at such, and after 3 seconds its speed is very fast. Okay, but now after 3 seconds it starts slowing down. Many of you, if you don't have practice of VT diagram, people think that it changed its direction, now it starts coming back. No, it is in positive direction. This is positive velocity that will still going away, but it will go away with very slower and slower velocity. So first it will slow down till 7 meters per second after 5 seconds. Further slow down till 8 seconds and stops here. At 8 seconds it stops because the velocity again became 0. And after that, can you see the velocity goes in negative zone? This is a negative velocity now. Now it has changed its direction and it becomes faster till some value which is very less than 7. That means the speed is very less, but it is coming in opposite direction. And then again, it slows down in opposite direction and stops after some time. So stops at here, maybe, oh, they've given 16 seconds. 16 seconds it stops. Okay, this is the interpretation of this particular graph. Let's see what is the question they're asking. Find the distance traveled by distance, okay, not displacement, okay, travel a particle in first 8 seconds. So they're asking in first 8 seconds how much distance has been traveled. So whenever you have a VT graph, just find the area under the curve, this area, and you'll get distance. Since it is in one direction, there's no need to write displacement, it is distance. Okay, so we can find the area by finding the area of this triangle plus this trapezium and plus this triangle. Only one problem in this case is that we don't know what is x. What is the value of this velocity? But we have a very good hint that the acceleration here is constant. A is constant because the gradient of this line is same throughout. So we can use kinematic equations. And the one we will use here will be V equal to U plus AT. Please keep in mind these equations can be used only for straight line graphs, VT graphs, okay? Because acceleration is constant. So V is this x, U we know is 0, it started from 0 meter per second, plus acceleration has been given from t0 to t3, the acceleration is 3 meters per second, and that's what we will use here. In this line, the acceleration is 3 meters per second square, and time is 3 seconds. So it becomes x equal to 9 meters per second. So we know that this value is 9 now, and that makes sense. It is more than 7, 9. All right, now we can find the area of this triangle. What is the area of triangle? So let's write distance, right? Distance from 0 to 3 seconds will be the area of this triangle, which is half base is 3, this is 3, height we know now is 9, so it comes 27 over 2. Just keep it like this. Second is this trapezium. Let me change the color for trapezium. This is the trapezium we are trying to find the area of now. So distance from 3 to 5 will be, area of trapezium is half first parallel line, which is this one 7, plus second parallel line, which is this one 9, times the space between that, this time 3 to 5 seconds is 2 seconds. So we can cancel this 2 and this 2, it becomes 16 meters. This was 27 over 2 meters. Third, this triangle. Distance from 5 to 8 seconds will be half base. Base is 5 to 8 is 3. Yeah, this is 3 and height is 7. So it becomes 21 over 2. And now we can add all three and we'll get our answer. So distance from 0 to 8 seconds, complete 0 to 8 seconds will be 27 over 2 plus 16 plus 21 over 2. It becomes 48. 27 plus 21 is 48, divided by 2 is 24, plus 16, 40 meters. So the learning here is the distance is found by finding the area under the graph of VT, and then we just add different parts. All right, shall we go to the second part? Given that when the particle comes to rest at t equal to 16, displacement from O is 32. All right, so that means after 16 seconds, when it comes to rest, this distance is 32 meters. What it means that this distance is 8 meters, right? 32 plus 8 will be 40, because from 0 to 8 we found 40. And now displacement, the word they have used is displacement. So shortest distance from the starting and the ending is 32 meters. That means the one from 8 to 16 is 8 meters. That means the area of this triangle is 8 meters. And we'll use the area of the triangle again and make it equal to 8. So do we know something here? Let's see. From 8 to 16 we know the base. Okay, so the distance from 8 to 16 is 8 meters. Yeah, we can call it distance. So equal to area of the triangle. Area of the triangle will be half base. Base is from 8 till 16, which is 8 times height. Height we don't know, and that's why they're saying find V, I think. Yes, they're saying find the value of V. Let's call it V. Whatever V we will get, we'll just write negative, okay? Because we know it's a negative direction. Right, currently we are just finding the area. So let's do cross multiplication. 2 multiplies with 8 becomes 8 multiplied by 2. This 8 becomes denominator and equal to V. So 2 and 2 cancel. It comes out to be 2 meters per second. And are they saying value of V? So yeah, we have to write minus. It is minus 2 meters per second. They're not saying find the speed. Find the value of V. And the value of V will be minus 2. Question 6, a particle moves in a straight line. It starts from rest. Okay, this is a key sentence. It starts from rest. So when time is 0, V is 0. That's what it means. It starts from rest. Obviously, the displacement is also 0 because it's starting from that point itself. So this is a fact from this line. Its acceleration at time t is given by this equation. Show that in subsequent motion, the acceleration of the particle when it comes to instantaneous rest is 16 meters per second squared. So it is already at rest when it starts, but the second time it comes to rest, we have to show that at that time, the acceleration is 16 meters per second squared. So to find out when it comes to rest, we should have velocity equation, right? And for velocity equation, we need to integrate acceleration equation, and that's how we get velocity equation. So if I integrate a with respect to time, I get v, and so in this case I have to integrate 0.4 t cube minus 4.8 t to the power half dt. So velocity equation will be 0.4 and t cube. 0.4 is untouched because it's multiplying. Whenever a constant multiplies with some variable, do not integrate this, just keep it like this. Integrate only the variable part, and the integration of t cube will be t to the power 4 over 4 minus, again 4.8 is a constant, keep it like this, add 1 to half, so it will be 3 over 2 divided by 3 over 2. So I have just 3 here, and 2 will be multiplying with the numerator. That's what I do all the time. Not to confuse, just write the numerator of the denominator here, and the denominator of the denominator becomes numerator multiplies with whatever is up, plus c. And now we have to find, let's simplify this one first. It becomes 0.1 and 3, and this comes 1.6 multiplied by 2, 3.2. all right, so let me simplify this. Velocity equation becomes 0.1 t to the power 4 minus 3.2, 1.6 times 2, 3.2 t to the power 3 over 2 plus c. Now before we proceed, we have to find the value of c, and this fact is going to help us now. That's why I immediately wrote this whenever I read in the equation. So whenever time is 0, velocity is 0. So velocity is 0 when time is 0, 0.1, 0 to the power 4. So this whole thing is 0 minus 3.2, 0 to the power 3 over 2. This is also 0 plus c. So everything is 0, c is 0. That means c is insignificant. We will not get any value for c here. So v remains. V equal to 0.1 t to the power 4 minus 3.2 t to the power 3 over 2. No c now. Now we want to find when it comes to instantaneous rest. Let's write this equal to 0 and not factor this. We'll just bring this to the right side. We do such when we are sure that t equal to 0 is one of the times that we don't factor it. Otherwise we need to factor, otherwise we lose one of the answers, right? In this case we already know one of the answers is t equal to 0, that we don't want. All right. So now divide both sides by, okay, let's get rid of 0.1 first. So 0.1 goes here. And t to the power 3 over 2 here, t to the power 3 over 2 here. So that it simplifies. 4 minus 3 over 2 will be t to the power 8 minus 2, 5 over 2 equal to 32. Yeah, this and this, 0 and 0 cancel, 32, this cancels. Okay, t 5 over 2 equal to 32. And now we need to find t in this case. So to find t, we have to get rid of the exponent. Whenever we want to get rid of an exponent, given further exponent, which is a reciprocal of this. So I give this another exponent 2/5. So I'll give that exponent to the right side also. So that 2/5 and 5 over 2 get cancelled out. We are left with only 2. And this gives us 30 to the power 2/5, 4 seconds. So now let's put this 4 seconds in our main equation to find acceleration at this time, because they're saying when it is at instantaneous rest, acceleration is 16 meter per second square, and the equation of acceleration is this. Let me do it here. I know it is 4, right? So it will be 0.44 cube minus 4.84 to the power half. Use your calculator and I'm sure it is going to be 16 meter per second square, which they want. Let's move to the second part of the same question. Find the displacement of the particle from O at t equal to 5. So basically we have to find S at 5. Okay, S is displacement, and to find displacement we have to integrate the equation of velocity again. This was the velocity equation and we have to integrate this again. So S equal to velocity integrated with respect to time, and it will be integration of 0.1 t to the power 4 minus 3.2 t to the power 3 over 2 dt. Okay, so again a constant multiplying with variable, so constant remains constant, 0.1 t to the power 5 over 5 minus 3.2, it will be t to the power 5 over 2, yes, plus 5 over 2 over 5 over 2, I multiply it here again, plus c. Now we have to find c before I go further. But we know the situation again. When time was 0, the displacement was also 0. So if I substitute both of them here, I'll get c equal to 0 again, because this is 0, t is 0, this t is 0, so c will be 0. So c is insignificant again. We just have this equation. So we need to find S5 now. S when t is 5. So it will be 0.1 5 to the power 5. Okay, if this 5 is only with this 5, okay, not with the 5 we're dividing with, so we should have written like this: minus 2 times 3.2 is 6.4 times 5 to the power 5 over 2 over 5. That's it. Just put this in a calculator and you will get the displacement when time is 5 seconds. By the time I do this, please subscribe to this channel and motivate me to make more videos along with learning points and detailed explanations of the solutions. Alright, when I put this in my calculator, I got minus 9.05 meters. That means it is going in the opposite direction of where it started from. The final question has given some detail about the vertical cross section of a slide. So read this part and then we'll proceed. You can pause the video for the time being. Okay, so clearly they're saying that the diagram shows the vertical cross section of the slide, and this part is rough, but from Q to R is smooth. Okay, so the first part says find the work done by friction during the motion of the particle from P to Q, because from P to Q it is rough. The friction will do some work in opposite direction. From Q to R it's smooth. There is no work done by the friction. So we just find it. So to work done is always the force multiplied by the distance and angle. If you want to additionally write angle between them, we can ignore cos theta because they are in opposite direction. The distance covered is in this direction, friction is in this direction, the angle between them is 180. Cos 180 is -1. So we will just assume that it is in opposite direction. -1 means it's in opposite direction. They're just saying that find the work done. They're not, work done, it is not a vector quantity, so we should not worry about the angle. So let's find the work done by the friction. So frictional force, we focus on friction because distance is known to us, 8 meters. We'll focus on friction only. Okay, so friction, let's call it frictional force, which is equal to mu r. Mu is given to us in this question, which is 0.5. R is the normal contact force, the reaction force for the particle. Let me draw the particle here, okay, before Q. So this is the weight of the particle, which is 0.25 multiplied by 10, which is 2.5. That is the weight of the particle. The component in this direction will be 2.5 cos alpha, because this angle is alpha. If you want me to explain, let's continue this to be here. This is 90 degree, we know this, right? This angle here will be 90 minus alpha, because the sum of this alpha and this angle will be 90. So if one angle is alpha, this will be 90 minus alpha. And this component is also making 90 degree here. So this angle becomes alpha again. That's why wherever is the angle being made, that component becomes cos. So this is cos alpha, and the reaction force is in this direction. Normal contact force is in this direction, which is not letting it sink into the slide. So this will also be 2.5 cos alpha, because there is no other force. So in place of R, we will write cos alpha now. So frictional force is 0.5 times 2.5, let's write multiplied by 2.5 cos alpha. Now alpha is not known to us. They have given here sine alpha is 0.8. So sine alpha is 0.8. That means alpha will be sine inverse 0.8. And I don't want to evaluate this. I want to leave this to my calculator. So what will I do? In place of angle, I'll write sine inverse 0.8. I do not take risk of rounding off and getting a little different answer than what is required. So I just write like this. Please keep in mind, this is an angle. This is an angle. However, our question was about the work done by friction. So we just found the frictional force, which is this whole thing, will multiply it by the distance, which is 8 meters, and we'll get the work done by the friction. So work done will be 0.5 multiplied by 2.5 multiplied by cos sine inverse 0.8 multiplied by the distance 8. Be very careful about this bracket, okay, so that this 8 does not multiply with the angle. So you can write 8 in starting also. If you don't want to confuse, you can write 8 at the starting. Just put this in a calculator and you'll get your answer. My answer is 6 joules. Let's move on to the second part. Hence, find the speed of the particle at Q. Okay, that means QR is out of context, we just have to talk about PQ. So you should know this basic equation for finding the velocity, the work energy equation, which is delta KE, difference in kinetic energy, plus delta PE, difference in potential energy, is the work done by the applied force minus work done by the resistive force. The work done by resistive force is known to us 6. There is no applied force. Once it was thrown, it was thrown. There was no other force during the journey of the particle. So it is 0. What is left is delta KE and delta PE. So for any of these two, we should always know that, for example, if I want to find delta KE, I should write half m and v square, final velocity square minus initial velocity square. What was the initial velocity with which it was released and what was the final velocity it reached there at. So initial velocity is 15 meters per second. They have given already 15 meters per second. Can you see here? This is 15 meters per second. And final velocity they are asking. So this is what we need to write here now. Half m. M is 0.25, the mass of the particle. Velocity final we don't know. I'll just write v here minus initial velocity is 15. We know this. Similarly, potential energy. Ng is common for final and initial. We'll write final height minus initial height. We know that initial height of the particle was at the ground, so there is no height, 0. Final height is the one we will have to look at this. This will be the final height, this one. Let me change the color for you. This one is the final height. So let me draw this triangle here. This is 8. This is alpha. This is the height we are interested in. So we can write that h over 8 equal to sine alpha, and h becomes 8 sine alpha. Sine alpha is given to us 0.8 again. So I'll use 8 multiplied by 0.8. That's the height, this h. So let me write it here. Plus m 0.25, g 10 fixed, and h we just got. It was 8 multiplied by 0.8, which is 6.4. Alright, we have everything here except for v. And let's simplify this, we'll get it. So this 2 can cancel with this. So it will be 0.125 v square minus 225. Can I do something here? Yes. 10 times 6.4 is 64 minus 0.25 times 64. You can use your calculator for doing everything here. So this remains here, 0.125 v square minus 225. So let's bring this to the right side, and before that this is going to be positive. It's a positive here, right? So it should have been positive here. This also keeps it positive, so it will be positive. When it comes to the right side, becomes negative. So minus 6 was already there, and this is 16. When it comes to the right side, becomes 16. So v square minus 225 equal to, this is minus 22, divided by this number 0.125. V square minus 225 equal to minus 176. So v square equal to minus 176 plus 225. Let's do the rest of it here. V square equal to 49. Then we square root both sides. V comes out to be 7 meters per second, because negative cannot be possible because it's going in the same direction, positive direction. We will just use this. Let's move on to the next one. Find the value of h. And what is h? Okay, h. Okay, h is the final height. What is the final height? So what will we do? We'll use the same equation, this, to get height. So delta KE plus delta PE equal to, there's no applied force, we know that, so let's leave it, minus work done by the resistive force. Okay, there is no work done from Q to R. The whatever work done by friction is from P to Q only. No Q to R, there is smooth. So no work done. So it will remain minus 6. Okay, delta KE will be half mass times, we know it stopped at R. That's what they wrote in equation. Somewhere. It comes to rest at R, right? So the final velocity is 0. So 0 square minus 15 square plus mg, height is, final height is h, initial height was 0, it was starting from ground. So we can find h now. That is the only thing unknown to us. So we can cancel this again. 0.125 minus 225 plus 2.5 h equal to minus 6. Let's bring this to the other side. Because of this minus, the whole thing is minus, but when it comes to the right side, it becomes positive. 2.5h equal to minus 6 plus 0.125 times 225. H will be minus 6 plus 0.125 times 225 divided by whatever is the coefficient, 2.5. I'll put this in my calculator and get the height. By the time I do this, as usual, please subscribe and motivate me to grow this channel to help you to solve questions with learning points. So when I use my calculator, I got 8.85 meters.